What's up YouTube? Optical Info back with another video. I'm starting a series on optics. Optics is can be frustrating at times, particularly when you first introduced to some of the concepts. So I just want to give you some food for thought, if nothing else, a little bit of entertainment maybe, something for you to mess around with at clinic, because the more you deal with it, the more you understand it. So anyhow, today in particular, this video is going to be on the Galilean Telescope, which is pretty cool. We use it all the time. You use it in the slit-lamp that you use every day. You use it on with loupes, like for oculoplastics, for sewing up a lid lac. You create it with, you do a backwards Galilean telescope if you over minus somebody, and that messes with the image size. So it has a lot of practical applications, and it's just sort of cool. Anyhow, so what is what is this Galilean telescope? But what is a telescope at all? Or to begin with, because there are different types. There's the astronomical and the Galilean. A telescope is a system of two lenses that doesn't create a image plane. It doesn't create an image. So what I mean by that, I mean, so you know, light is always diverging in the natural world unless it hits a converging lens. You know, it's always diverging. So for example, the point, like if we just take a little point on my nose here, the light hits it, and this infinitely small point, and the light rays, you know, an infinite number of light rays diverge away from this point. And unless those light rays are converged back into a point somewhere out in space, via a converging lens, then it never creates an image. Your eye has converging lenses in it, so when the diverging light rays from my nose hit the converging lens in your eye, it's recreated back to a point, and then that image is formed on the retina, and then your brain sees it. So, but with an astronomical telescope, that point is, you know, it's the light rays coming from my nose. You know, I'd be really far away for if we were using a telescope. They'd be coming in parallel, and they'd be leaving parallel. So it's afocal. It doesn't create a focal plane like a simple converging lens does. And I have a picture of that here that may make things a little bit simpler. All right, so I'll just show this to you. So the light rays are coming in parallel, converging. They would focus right here on this focal plane, but are being intercepted by a diverging lens, so that they are still exiting the lens system in parallel. So they come in parallel, leave parallel. And the way these two, this is a converging lens, and this is a diverging lens. The way these two things are oriented is so that they have the same focal point right here. Okay, so that's key. You have to hold these two lenses so that they both have the same focal point right here, and that'll allow it to come in parallel and leave parallel. And meanwhile, the angle right here at which these lights are coming in is not as steep as this angle, so the diverging lens is stronger. It's a stronger lens, so it's torquing the light rays harder, and as a result, it's magnifying the image via that angular magnification. So it's subtending a larger area of your retina, so it looks bigger, as if you moved closer to it. So that's what that is. And look, so so this is what I want you to do. Just grab some lenses from work. If you're doing the Galilean telescope, then you'd want a plus and a minus lens. And remember, the whole point of a telescope is sort of like to create a system where you have a fulcrum and you torque the angle. So the lens that's closer to your face is going to be a stronger one, because that's what's doing the torquing. That's what's creating that fulcrum in a steeper angle to make the image look larger. So here I snagged this is a +5, and here's a -10, And so we can just hold these up. And so actually I'll do it for you. So I'm going to put the stronger minus towards you. I'll just put it like that, and then hold this one. And now see, I have to get it to the right distance so that the focal points are in alignment here. Let's see if I can figure it out. We switch hands. So I'll put that over and then hold this up. Yeah, there you go. You can see things maybe behind me here. Yeah, okay, so you get the idea. And look, if you did this backwards, you'd get the reverse. See it's minified now. So that's what can happen if you over minus a patient. And then the other thing, OCAPs are with their boards, they want you to know a little bit of optics, so we'll do that real quick. So in this case, I had a +5 converging lens, so I'll just draw that out. Make sure you can see this. +5, because they always want to ask you, like, where should you hold these? How close do you hold the lenses in order to get that afocal system to where they come in parallel and leave parallel? So you have to just align the focal point. So that's all we're going to do in this problem here. So this is +5. I'll write that a little bit more legible. +5. So imagine light rays are going to come in and be focused. Where are they going to be? How far away? When in doubt, take a reciprocal. 1/5 is 0.2 meters, which is 20 centimeters. So we'll just go like this. Call that 20 centimeters, okay? So here's the focal point. And now we want to put in a stronger diverging lens that has the same focal point. I grabbed a -10. So I'm just going to draw this in here somewhere, and I'll draw it bigger to signify that it's stronger. -10. Where's the focal point for -10? When in doubt, take a reciprocal. 1/10 is 0.1 meters, which is 10 centimeters. So this needs to be 10 centimeters away from that very same point. And so what's going to be, how far apart do I hold these things? Well, 20 minus 10 is 10. So just 10 centimeters is the distance between the two lenses. Yeah, and then also another neat thing, if you which may help grasp this concept, this the image that would be created by this converging lens, you can actually see that if I hold up. This is a different lens. It's a 20 dot. It's my 20. So if I just hold this up 1/20 meters away, which is 0.05, which is 0.05 meters or 5 centimeters. If I just hold this up 5 centimeters away, oh come on, sort of hard to do with boom, there you go. So there's an image where you have all these parallel light rays coming in from down the road. You can even see like a car coming in there. You have all these light rays coming in from parallel, being converged to a point, creating an aerial image. I can see the image here if I just get behind the lens. I can see that same thing that you're seeing when I hold this paper up. And this is what we do during retinoscopy. Okay, so the parallel light rays are converged from an infinite number of individual points. Light rays are diverging from an infinite number of individual points, and then those divergent or those parallel light rays are being recreated to a point. They intersect where I'm holding the piece of paper, and it's forming an image of all those points, and together to some of the picture to some of its parts, and it creates an image plane. And so that's what you're seeing here. And that's also what I'm seeing when I just get behind it. I see that same image right there, just like in directed retinoscopy. And then the only difference with this telescope is that we're taking a stronger, in this case this is not as strong as a 20, so I gotta switch this out here. We're taking a stronger divergent lens, so that before that image plane is created, I shove this in there and intercept the converging rays to diverge them so that they still exit in parallel. But because it's a stronger lens, it's torqued at a harder angle, and so it's angularly magnified. So try that out. Now you can just bust your 20 out one day when it's bright, and hold it up against something white, and you can see that it forms an image plane, an aerial image that you can intercept with a piece of paper, or you can just get behind it and see the same exact thing. And then when you're in clinic one day, snag some lenses. You don't have to do any math immediately. Just get a minus and a plus. Make sure the minus is stronger and put it closer to your face, and just sort of mess with it till you figure it out. And then maybe that'll help it stick for OCAPs. So yeah, I hope you enjoyed this. I'll catch you in the next one. Peace.